Hello and welcome to today's chemistry class. For this class, we'll learn the concept of equilibrium constant. So let's discuss the concept behind equilibrium constant. First things first here, I would like to define what is equilibrium, right? First things first. So let's discuss about what is equilibrium. Then look at the concept of equilibrium of equilibrium constant. After that, we'll look at its mathematical representation. So first things first, what is equilibrium? Equilibrium. This occurs when there is no observable change in the property of a system with respect to time. So it's important to note that equilibrium occurs when there is no observable change in the property of a system, right, with respect to time. That is equilibrium, right? I want to explain the idea behind equilibrium. The next task here is to define what do we mean by equilibrium constant. First things first, by definition, equilibrium constant is the mathematical ratio of products to reactants. So to define equilibrium constant, we said it is the mathematical representation of the ratio of product to reactant, right? And it is represented by K by K. So equilibrium constant is represented by a symbol called K, and it is the ratio of product to reactants. That is how you define the idea of equilibrium constant. So say this please. So let's say for equilibrium constant, what is the idea of equation? No, we said last in our last class when we look at chemical reaction, we said we represent a chemical reaction using a chemical equation, right? Elements are represented using symbol. Chemical reaction are represented using what there? Using a chemical equation. Alright, so let's take a chemical equation. We know that for a chemical equation, you have only two parts there. What part and what part? You have the reactant side and of course what there? The product side. So let's say I have reactants or perhaps reactants undergoing chemical reaction to give you product or several products, right? In a case like this where I have my reactants and of course my product side, how do I find my equilibrium constant? It's simple as, if you observe, we said equilibrium constant is what? It's K, and it's equal to what there? The ratio of what? Product. So I have the concentration of product or several products, right, all over the concentration of reactants or reactants 1, 2. So this is your mathematical representation for equilibrium constant, the ratio of product first to each what the reactant. This is how you define the concept of equilibrium constant. And by the way, I call this bracket, I call it what the concentration. So the concentration of product to each what the concentration of what? Reactants. That's how you work with this concept. Here's the thing, please. Usually when you have a chemical equation such as reactants and products, if you observe very well, you know that to form a chemical equation, you need either two or one or more of elements here to give you products, right? If you observe, there will be sometimes they do have coefficients, right? Probably, let's say for that I'm having 2NO to give you 3SO. Let's assume, I'm assuming please, this is not correct, but I'm assuming. You see this has a coefficient of 2 and 3. These 3 and these 2 are called coefficients. So what of if your reactant and product are having a value in their front, they're having a coefficient? So I'm saying this please. So for coefficient, in a case whereby coefficient exists, like numbers like this exist, what do you use as your formula for equilibrium constant? And by the way, so let's assume that my coefficient here is m, my coefficient here is n. So I'm considering coefficient of what? M, and what there? And n. My reactant is having m, my product is having what there? N as the coefficient. What will not be the formula for my equilibrium constant? That gives you, that's K will be equal to what there? It said product, product conference, and my product is having n as coefficient. That gives you product, the constitution of what? Of product. Now this coefficient that is here will not come up here. It will be here all over the coefficient of, it's all over the concentration of what? Reactant, right? Then that coefficient will come up here, m. So this is how you express the formula for equilibrium constant in two ways. In a way, the first one here is when you're not having coefficients number in their front, like something like this. Probably you're having something of this nature, just SO and NO. You use this formula. We're having a value in their front, a coefficient. So in the coefficient case, let's say I'm having m as a coefficient here and n as a coefficient here. Your formula becomes this nature. So the product first, then that coefficient comes up here, becomes the power, and the reactant, that coefficient becomes what there? The power. This is how you work with the idea of equilibrium constant. At this junction here, let's take some sample problems and see how we can work with the idea of equilibrium constant. Sample problem 1. Sample problem 1. Alright, so I have sample problem 1. Alright. So it says, so let's it says I have a chemical equation. It says I have small a, then capital A, plus small b, then capital B, to give you C with capital C, plus D with capital D. If you observe, these two here are on the reactant side, these two here are on the product side. So in a case like this, what do you do? We know that K, to get the equilibrium constant here, we know that K is what? Product before what there? Reactant. That's good. Now in this case, I have what? More than what? One product. And by the way, you see this B has a coefficient of B. This A has a coefficient of what? Small a. This D has a coefficient of what? Small d. Why this C also has the coefficient of what? Small c. What do you do in this case? In this case, I have two products, not just one product. That gives you the first product first. That gives you C. This C. What's the coefficient? Small c. Alright. Dot. You're multiplying it. Dot. The second product is what? Is D. So the constitution of D and the coefficient is what? Is small d. Alright. All over. In this case here, my reactant is 2, right? 1 and 1. So I need to separate them. So this first one, that gives constitution of what? Constitution of A. This is my coefficient here. That comes up here. Dot. Of course, I'm having B. The constitution of B. Constitution of B. And I have my small b up here. This is how you get the idea. This is what we refer to as equilibrium constant. The ratio of the product or several products, as in this case, to reactant or several reactants, as in this case, as you can see. And mind you, because I'm having plus here, that does not mean I should be having plus here. No, you are multiplying them, right? So that's how you work with this concept, as you can see on the board. At this junction, let's dive into several past questions in the study of equilibrium constants. Another example in the study of equilibrium constants. So, about number 2, it says in the decomposition of calcium triazo carbonate 4 to give calcium monoxide of or calcium 2 oxide and carbon 4 oxide as shown in the equation below. All right, so it means that question has a chemical equation. So on the board, I have it here: CaCO3. This is your reverse concept, right? To give you CaO here in solid, plus CO2, of course, in gas. So as I was saying, I said this is the chemical equation given to us, right? So what I just read outside is the written word of the chemical equation. So this is what we have here. So in this question here, this is solid gas. You're having gas state. Also, this one too is in solid state, right? So by the way, first things first, you are for every equilibrium constant there, you'll be given a chemical equation. You'll be asked to find its equilibrium constant. So in this case here, we're given calcium carbonate 4 with calcium monoxide, also with what the carbon 4 oxide. So we are given this let's say 3 compounds here undergoing a chemical reaction. By the way, here, this one here is your reactant side, and this one is what your product side. Before you find your equilibrium constant, your first task there is to balance your equation. Ask yourself, is this equation balanced? If yes, proceed. If no, balance them first before you proceed to find equilibrium constants. So I'm saying this, please, if you observe properly on my reactant. So the idea of balancing equation is to ensure that the number of mole on the reactant side and product side are the same thing. And while balancing chemical equation, subscripts are not used, just whole number coefficient, right? So here's the thing, please, and I'll leave a link on how to balance chemical equation. I've done a video on how to balance chemical equation, so I'll leave the link to the video in this video description. So check this video description. You see a link that will take you to our class, our tutorial class on how to balance chemical equations. So let's check mates, this checklist. Anyways, so let's check if the reactant side and product side number of mole are the same. So let's balance this. This is first. This is calcium. I'm having calcium is 1 here. On my product side, calcium is 1, so no problem. Calcium is balanced. If you check your reactant side, this is carbon. It's just 1 here. On the reactant side here, carbon 2 is just 1. It's balanced. If you observe on my reactant side, oxygen is 3. Product side here 2. Oxygen is what? 2 here with 1. So 2 with 1 gives you a 3. So this equation here, this chemical equation in quotes, is balanced. I haven't confirmed that it's balanced. You cannot proceed to solve the equilibrium constant. And we said, we said equilibrium constant, that's K, is equal to the ratio of the products, concentration, please, products or several products all over the concentration of what? Your reactant reactants or several reactants, right? If possible, if you have your what's it called coefficient there, you can attach them here and here. In this first question here, there is no coefficient. There is no number in this front here, no number here, and no number here. So in other words, there I don't have to attach any coefficient. So in other words, my equilibrium constant K in this case will be equal to my product is what? In this case, I have what? More than one product, 1 and 2. So pick them one by one. That gives you the concentration of what? Of CaO, right? Dot. For this one there, CO2, CO2, right? So all over. For what's the reactant place? Just this one here, CaCO3. That's of course concentration of what? Calcium triosocarbonate 4. Alright. So this becomes your answer to this particular question. That is all. Right, that's all. This is a solved problem when it comes to equilibrium constants. So let's do sample problem 2. So this becomes your answer. Alright, so number 3. Let's do sample problem 3. Alright. Okay, so for this one here, question 3 says write the equilibrium constant for the reaction of nitrogen with hydrogen to form ammonia. It says write the equilibrium constant, that of course K, right, for the reaction of nitrogen with hydrogen to form ammonia. By the way, please don't stress yourself. Every question they will give you a possible attachment of of a chemical equation. In this case here, the attachment here was N2, of course, in gaseous state, plus hydrogen, of course, 2 hydrogen, of course, in gaseous state, to give you a product of what? Ammonia, NH3, of course, this man here in gaseous state. This is your chemical equation given. Please don't forget I said before you can find K in this case, don't just jump and look for K. Ask yourself, is this equation balanced first? If you check this properly, you see that I have N2. My N is 2 here, no problem. But if you check here, my N is just 1. So here's the tax here. I have to put 2 here. So it means 1 times 2 gives you 2. So, and by the way, these 2 will affect every element here, right? So let's go back again. N2 to balance the equation. I will leave a link in this video description. So go and watch the video to understand this. I won't start stressing myself here, teaching you guys how to balance the equation. So watch the previous class, right, on how to balance the equation. So by now, I expect you should know how to balance the equation, right? So I'm saying this, please. For teaching's sake, I will explain better, right? N2, this is nitrogen, and it's 2 here. What I did here was nitrogen was just 1 here. So balance this nitrogen, I have to put 2 here. And putting 2 here will affect both nitrogen and hydrogen, right? So it means nitrogen is 2, of course 2 here, no problem. Moving on, I have hydrogen. Hydrogen is 2 here. But in this case, hydrogen is not just 3. These 2 will affect hydrogen. That gives you 2 times 3 gives you 6. In the product side here, I have 6 hydrogen. Right hand side, I have just 2. So balance this 2, I have to put what there? 3 here. So in other words, this gives you 2 times 3, that gives you 6 hydrogen here. 6 hydrogen here. 2 nitrogen here. Of course, 2 nitrogen here. This equation is now balanced. Please, this is now balanced. For clarity, as you are writing, first things first, write out what I gave you initially first, before this answer. I gave you N2, H2, and NH3. Write that one first. You now come down and write this answer to avoid confusion, right? So this is my balanced equation. In this case here, observe that I'm having coefficient, right? This one has no coefficient. So in other words here, I'm bringing the idea of coefficient concept here. What do we do? What do we know? We said to find k is equal to what there? Your product side first. So this product side comes in. That gives you the concentration of NH3, right? By the way, I should have leave it this way. But I'm having what there? A coefficient of 2. That comes up here. 2 all over the reactant side. I have 2 stuff here. That gives you the concentration of what? N2. No, this one has no coefficient, so I'll leave this blank. Dot. I have H2. That gives you H2, and my H2 is having a coefficient of what? Of 3. So I'll put the 3 here. This becomes your equilibrium constant to this particular chemical reaction, or perhaps chemical equation, right? Because I said we represent chemical reaction using what there? A chemical equation. So whichever one you want to call it there, that's it, fine. So this is what you have at this junction. So it becomes your answer to this particular question. Let's do number 4. All right, sample problem 4. All right. So let's do problem 4. What do we get? 4. All right. It says nitrogen reacts with chlorine to produce nitrogen trichloride. At equilibrium, the concentration of each gas was found to be N to be equal to 0.15 mole, Cl to be equal to 0.25 mole, and NCl3 equal to 0.5 mole. NCl3 is equal to 0.50 mole, not 0.5, 0.50 mole. Now says calculate the value of equilibrium constant. I said again, every question they will attach a chemical equation there. In this case here, my chemical equation is given to be N2 plus Cl2 in gaseous state. This undergo chemical reaction to give you NCl3. Of course, this man also in a gaseous state, right? So you are given this chemical reaction. So your first task, we know before now that we have to balance this up. But then, if you observe very well, they gave us the value of the concentration of each gas, right? They give us nitrogen as 0.15, chlorine as 0.25, and NCl3. That's what the nitrogen trichloride to be what there 0.50 mole. So it means that after finding your K in this format, you have to insert those values of the given elements into the expressions. What do I mean? First things first, I'll balance this first. To balance this up, we said n is 2 here, n is 1 here. You know what here? I have to come here and put 2 here. So 1 times 2 gives you n is 2. But by the way, these 2 will affect chlorine too. Moving on, N2, fine, no problem. Nitrogen is balanced. Chlorine is just 2 here. It's this 3 here. And this 3, these 2 are affected. So that gives you 2 times 3. That gives you a total of 6 chlorine. Yeah, I'm having what there? Just 2 chlorine. So in other words, I can put 3 here. So that in other words, I'll have 2 times 2. That gives you a 6 chlorine on the other side. 6 chlorine on what there? Not side. This equation is now balanced. As I said, always write out the original form first before this answer. Now, to get my K, it's simple as we said K is equal to product first. So this one comes first. That's NCl3. By the way, this is my NCl3. This 2 is my coefficient here. So I'll attach it up here. Up to the power of 2. Right? So all over I have 2 reactants here. So I have 2 reactants here. That gives you concentration of what? N2. Please, this N2 has no coefficient, so I'll leave here blank. Dot. Moving on, I have Cl2. That gives you Cl2. And by the way, this Cl2 has a coefficient of what? 3. So I'll put the 3 as a pi here. This becomes your expression to equilibrium constant. And by the way, I should have stopped here. But the question proceeded and said they gave us the concentration value. They give us a value for NCl3 and nitrogen and water and chlorine. So we have to put in those values here and solve mathematically, right? So that gives us about, I think NCl3 is 0.50 mole. All right, let's get that done. Let's get that done. Okay. This gives us K will be equal to, if you check properly, check for NCl3. I said NCl3 is 0.50, please. 50 mole. That is for NCl3. I have to power of 2, that is power of 2. All over, I'm having N2. N2, check your notes, your example I gave you now. N2, by the way, coming. N2 is what? 0.15. That gives you 0.15. Alright. All to the power of what there? Nothing. I have nothing here. There's no pi here. Then dot. Concentration of what? Cl2. What Cl? That's 0.25. The pi here should be what there? 3. I have 3 to the pi. Moving on there, K will be equal to, if I press 0.50 square, I'll have about 0.25 all over. If I punch my calculator, if I punch these two together, I'll have about 0.00234 If I punch these two on my calculator, I'll have this value. Divide them together, I'll have that K, which is my equilibrium constant, to be equal to I have 106.67. Please note that equilibrium constant has no SI unit. I'm going to put kilogram here or joules. It has no SI units. Why? Because something constant. The anything that is constant usually have they don't have SI units. So it means that my equilibrium constant in this case here is of course 106.67, and mind you, it has no SI units. Let's do question 5. Let's do question 5. Okay, question 5. Question 5. Question 5. Sample problem 5. Sample problem 5. Alright. This one it says they gave you a chemical equation SO2 initial state plus O2, of course, in initial state, in a reverse format to give you SO3. This man too in gaseous state, right? So the task is this, please. They give us the value of SO3. SO3. This man, the value to be. This bracket means concentration to be 0.45 mole. This will give us for SO2, right, to be 0.10 mole, right, and they give us K to be, that's equilibrium constant, to be 37.5. And I said, what is the concentration of the oxygen there? We are asked to find oxygen concentration, right, in this reaction. So what do you do? So first things first, it's simple concept here. Alright, so let's solve problem 5. So first things first, it says you're having SO2 plus oxygen, 2 oxygen, and of course SO3. What do you do to balance this? It's simple as this, please. First things first, I said to balance the equation, your task is to ensure that number of mole on the reactant side and the product side are the same. What do we mean? S is 1 here, S is 1 here, no problem. The issue is this: oxygen is what? 2 here and 2. That gives you 4 oxygen here. Here is just what there? 3 oxygen. So to make this balance properly, if I put 2 here, these 2 will distort sulfur. So this one here gives you 2 sulfur. I have to put 2 here to balance what there? 2 sulfur. So if I have 2 sulfur, now 2 times 2 gives you 4 oxygen here. 4 with 2, that gives you 6. 2 times 3 gives you 6 oxygen. This is now balanced, right? 2 times 3 gives you 6 oxygen. 2 times 2 gives you 4, plus 2 gives you 6, right? So this becomes now a balanced equation. And by the way, this one has a coefficient. This one has no coefficient. This one has what there? A coefficient. What do? We said to get, the goal is this: we're no longer looking for a equilibrium constant because it's given as what? 7.5. All I have to look for is what? Oxygen, right? The concentration of oxygen. So we know that K is equal to product first. I'm having what there? SO3, concentration of what? The power here is 2 because the coefficient here is 2. We have 2 here. So all over product side, reactant side, that gives you SO2. This man here will be having what there? 2 as the power here. So dot, what's next there? Oxygen, O2. I'll be having the power here to be nothing because it has no coefficient, right? So we are asked to look, we're looking for this. So we know that K is what? 67.5 to be equal to, what's this one here? SO3. That's 0.45 all over SO2. That's 0.1. That gives you 0.110. Then I have O2 that I'm looking for. I have my O2 that I'm looking for. Right? My next task now is what? I'll cross multiply. So here mass comes to play here, right? So the level of math understanding comes to play here. So I'll be having I'll have that this gives you of course invisible one is here. So this times 1 gives you 0.45 to be equal to this times this, that gives you 67.5 multiplied by 0.10 multiplied by what there is, oxygen O2. O2. Alright. This gives you 0. What there? 45 to be equal to, multiply this together. What do I get? Calculator. That will give about sorry, okay, yeah, that give about 0.675, then my oxygen concentration I'm looking for. To get this one, I'll have to make such a formula. I have to divide both sides by what? 0.675. So divide by 0.675. That gives you 0.45 all over 0.675 is equal to 0.675, of course, my oxygen concentration, all over what there? 0.675. This will cancel this. It means that my oxygen concentration I'm looking for will be equal to, divide this 2, that will give 0.3, of course, mole. So it becomes your answer to this particular. There was a mole here, M here, there's an M here. That's the SI unit here, MM. So this becomes your answer to this particular question. This is how you solve problems of this nature. Alright, if you found this class helpful, do well to like this video, share to your friends and classmates, also subscribe to this channel and leave a comment. Right, also do well to join our WhatsApp community. I have the link to WhatsApp community in the video description, so check the video description. You see a link that will take you to our WhatsApp community. And also, you can get more of my interesting classes on my website. I'll display my website on the screen, as you can see. You can visit my website and get more amazing classes of this kind on my website. And also, I just launched a book called The Shortcut to Academic Success. I'll display the front page of the book on the screen here. You can get a book. If you want to get a book, it's free. You can get a book. You check the video description. I'll leave a link that will take you to where you can get the ebook of this the shortcut to academic success. Right. So see you guys in the next class, and welcome to Excellent Link Academy. Do what subscribe. Do what to subscribe to this channel. Alright, see you guys in the next class.